Low Earth orbit or LEO amateur radio satellites move across the sky rather fast so that a typical pass of International Space Station lasts about 10 minutes from horizon to horizon. LEO satellites, which are located at higher altitudes like Lilac-Sat 2 and Saudi-Sat 50, take a little more time to complete the pass from horizon to horizon. Medium Earth orbit or MEO amateur radio satellite located at much higher altitude takes about 90 minutes to complete one pass. The pass direction is across the sky in both vertical and horizontal axes. Tracking the horizontal direction, like north to south, is known as azimuth, while tracking vertical direction is known as elevation tracking. A satellite tracking antenna needs to move along azimuth and elevation to track the satellite exactly to receive the relatively weak signals well. This is done using an azimuth elevation antenna rotator. Azimuth elevation antenna rotators are naturally more complex and expensive than a simple azimuth antenna rotator, which was commonly used in yesteryears to change the direction of the television antenna to receive stations from different directions. It is needless to say that antenna rotators are not needed for omnidirectional satellite antennas like egg beater. Though egg beater antenna is also circularly polarized and better than a simple ground plane antenna for satellite operations, the ideal one will be a cross Yagi with multiple elements which have high gain and low beam width. These cross Yagis, and for that matter any Yagi with a good gain, will need careful tracking of the direction of pass of the satellite to receive the signals from horizon to horizon. Some use two rotators, one for azimuth and another for elevation. But that makes controlling more difficult as you have two controls to work on in addition to Doppler tracking of your radio during the pass. Yet it may be cheaper as azimuth elevation rotators are quite expensive. When I checked just now, an EASO G5500 DC azimuth elevation rotator system costs $759.99, while my full duplex VHF-UHF radio for FM satellite operations costs just $309.95. The landed cost in my region will be much more, taking into consideration the shipping charges and taxes. That is why I am yet to go for an azimuth elevation rotator, though it limits the satellite passes which I can work. It is also one of the reasons why most satellite enthusiasts work outdoors with either a handheld Yagi or a Yagi mounted on a tripod and rotated manually. There is also a simpler option of going for azimuth only rotator as used for an HF beam antenna. They are much cheaper and some have even homebrewed it with Arduino based controllers as well. One operator in my region keeps the dual band VHF-UHF cross Yagis for LEO satellite operations mounted on a crossbar and kept at a fixed elevation of about 15 degrees. Using an azimuth only rotator, he has worked a lot of DX on linear amateur radio satellites. Though keeping at a fixed low elevation will not be ideal for high elevation passes, they are good for long distance contacts. In our region with a low number of satellite operators, it gives more opportunities for satellite operations than an antenna which focus on high elevation passes. Beyond LEO and MEO satellite operations, azimuth elevation rotators are also needed for Earth-Moon-Earth or EME, also known as moon bounce contacts, bouncing your signals off the moon at a distance of nearly 384,400 km. Moon moves across the sky much slowly than LEO and MEO satellites, and fast tracking rotator is not needed. But the huge distance makes highly directional multi-element Yagis, often in huge arrays, or a large dish antenna for higher frequencies, a must for successful moon-bound operations. Yet, special Q55 digital mode available in WSJT-X software for weak EME signals is making moonbounds much more popular than in yesteryears.